We will now begin our fifth session titled AI and Reorganization of the Body-Machine Society Relationship. And this session will be moderated by Ms. Sumaya Al-Hadrami, Deputy Head of the Global Sector at Trends Research and Advisory. And we are honored to welcome the following distinguished panelists. Professor Masahiko Inami, Professor at Arcas University of Tokyo. Dr. Yasuki Munai, Associate Professor at Arcas University of Tokyo. Dr. Ernesto Damiani, Director of the Khalifa University Center for Cyber Physical Systems. Professor Abdul Muttalib Al-Sadiq, Adjunct Professor of Human-Computer Interaction at MBZU AI. And Ms. Amina Al-Marri, Researcher at the Autonomous Robotics Research Center, ARRC.
Good morning. My name is Sumaya Al-Hadrami, and I'm Deputy Head of Trans Global Sector. The discussions we have enjoyed so far have highlighted the profound transformative effect of AI across international relations, geopolitics, conflict, environment, energy security, and others. And as we shift our focus towards understanding the future relationship between AI and society, I am delighted to moderate this panel of leading experts on human AI integration and human AI interfaces. As the leading edge of AI's potential to impact our lives, we have the possibility to enhance human sensory, motor, intellectual functions through body augmentation engineering. From a technology standpoint, human augmentation can take place in both virtual and physical environments through virtual reality, augmented reality, or robotics. And from a social standpoint, these approaches could potentially address pressing challenges, including hyper-aging populations in Japan and around the world. This panel is about recognizing and exploring these new and potentially transformative perspectives. And with that, it is with great pleasure that I turn to introducing our 5 panelists. As we begin this discussion, I would like to first allow Professor Masahiko Inami, Professor at Research Center for Advanced Science and Technology, and leads the Inami Munai Research Laboratory of the University of Tokyo, to begin his presentation. Please, Professor.
Thank you very much. I'm very happy to hear. So let me introduce our research activities at first. So the title is Next Steps for Human AI Integration. So I'm Masa Inami, and I'm also Deputy Director of this research institute, Research Center for Advanced Science and Technology. So me and Professor Monnai is co-PI of Information Somatics Laboratory. So we are collaborating with 9 colleagues in our laboratory, and so our research interest is very broad. But any IT technology or AI technology relates to our body or our human. So one of my research achievement is, maybe do you know Nintendo Switch? That is a portable game. When you play Nintendo Switch, you are able to feel some slight vibration or haptic interaction. Maybe actually they use our patent for their game machine. And so we have also developed one wearable glasses, which name is Jeans Meme, collaborating with Jeans Inc. That is one of the biggest glassware industry in Japan. And so based on our collaboration, they developed a commercial product which allows us to perceive how you are focusing on or how you are sleeping. Maybe if you put our Jeans Meme, we can estimate you are focusing on our discussion or not. And so we have also developed meta rims, that is supernumerary rims. And also one of our famous research achievement is called optical camouflage system. That is a sort of projector-based system, but you are able to observe myself become transparent. Today, I don't have special clothes, so you can see my body at this time. And so our current research interest is Jizai Body project. We can also say that is virtual cyborg project. So unlike physical cyborg, by using digital transformation, this is a sort of digital transformation technology for our body in order to expand so our ability, not only in physical world, but also in cyber world. So that is so cyber physical world. And in order to enhance our activity or expand our activity, so we are planning to redesign so our body by using robotics and AI and virtual reality technology. So in this case, so top left, so you can see that is a robotic tail. So by using such kind of tail, so you can keep so a sort of that is a sort of auto balancer, even if so you are pulled from left side. And so right, the top right is so one example extra limbs, and so on the bottom left, so that is so the center avatar is a sort of average avatar. The which motion, which movement can be controlled with two people, so right person and left person. And surprisingly, the activity of integrated avatar is better than individuals with some reason. And that is so one ability how we use the virtual avatar control with several people. That is somehow similar concept with so Japanese traditional the puppet theater. It is called the bunraku. And bottom right is that is sort of so offshoot scenario. So one person by using so virtual reality or metaverse plus some AI, so we are able to control 4 splitted body simultaneously by using that technology. And so and this is also recent research achievement. So collaborate with Professor Yamanaka to enhance ability of expression in dance performance, which is called Jizai arms.
Digital cyborgs, powered by wearable robotics, raise important societal questions about their integration into our world. We explore intriguing questions about our relationship with digital cyborgs. Will you share or exchange your body parts with others? Will we love our robotic body parts? Will you mourn and memorialize them after our death? To address these questions, we have produced Jizai Arms, a wearable robotic system. The term Jizai originates from the Sanskrit word Ishvara, which means a supreme being free from earthly desires and constraints. The Jizai Arms provide an unexplored sense of Jizai-ness and visually present the scenes that digital cyborgs can create. We explore how individuals might adopt or resist the digital cyborg technologies, and whether they will embrace or reject the idea of transforming into digital cyborgs.
And so based on our experience, so we can say, so how we collaborate, how we use a relationship between human and AIs. So one of our research field is called augmented reality. And but so now we can say that is AR or XR. But so before 1990, so AR was called, so AR was based on, AR is called, so artificial reality. So it used to be artificial reality. Now we are use AR as augmented reality. So, and now many people believe so AI is one of the strongest and emerging technology, which is that is artificial intelligence. But why don't we follow the scenario of AR? So we can say AI as so augmented intelligence or so assistive intelligence. So which that is not our enemy. So we are able to acquire ability of AI. So by using human AI integration technology, such as so Jizai arms. And so we have already established international community. So that is so Dagushul seminars, that is next step for human computer, human AI integration. And so actually, so I'm one of the steering committee of Human Augmentation Conference, which is named Augmented Humans Conference. And fortunately, So we will organize our conference in Abu Dhabi around late February or early March 2025. So that is also a good opportunity to continue our discussion, not only in Japan or Tokyo, but also in UAE. And so for more details, please read our book. That is, so Seorevo Jizai Body. So thank you very much.
Thank you so much, Professor Inami. I guess the possibilities of utilizing augmented reality is truly fascinating, and we're all excited to know more and about what the future has for us. I now have the pleasure to introduce Dr. Yasuaki Monai, who is an associate professor at RCAST and co-lead of the Inami Monai Lab at the University of Tokyo. Please go ahead. Thank you.
Thanks for the introduction. I'm Yasuaki Monai, an associate professor in the University of Tokyo, RCAST. And let me introduce briefly what I've been doing recently. And can I turn the page myself? Or? Okay, thanks. Okay, I have now, I've been working with Professor Inami for like 3 years, and recently I've been working especially on the so-called novel wireless technology, which is terahertz technology. And terahertz means the electromagnetic spectrum that is located between the conventional radio wave and optical waves. So there is a new emerging opportunities, which was difficult in the 20s during the 20th century, but probably we can do something in the 21st century and beyond. And when we control those radio waves or microwaves, we always use an antenna for sure. So each mobiles, laptops are equipped with antennas. But the antenna is made of metal rod. Antenna is just a metal rod. But in the optics, we do not use antennas, but we use optical lenses. So lens is a glass sphere or plastic spheres. So to control microwaves, we need a metal rod. To control optics, we need a glass sphere. So there is a technical gap between those two regions. So what comes in between in the terahertz frequency? That is our basic motivation, fundamental motivation. And specifically, we have developed wave guiding structures and antenna structures for these terahertz frequencies, because for any sort of wireless applications, we need terahertz beam forming and terahertz beam steering to deliver the information signals or measurement signals. And in the meantime, the reason why we got interested in terahertz and the reason why we are collaborating with Professor Inami is that the terahertz has a potential for especially the human-oriented applications. The wavelength nature of the terahertz waves have huge possibilities. For example, we have developed a structure or device that can be used as a non-contact stethoscope that detects your heartbeat motion, for example, in a non-contact and remote manner. So this kind of wireless technology allows no physical restricts on your body to measure your body activities. And also the main topic that we are focusing currently is to convert the ultrasound, terahertz waves into ultrasound. Ultrasound is used to measure and sense inside of our bodies, but terahertz waves can be converted into such ultrasound signals. So let me briefly explain what this non-contact ultrasound idea means. In order to do ultrasound echo imaging, for example, we always need a physical contact of the probes or transducers on our skins. Most probably, they are pasting gels on your skin surface. But this restricts your free body motion. So ultrasound imaging can be used maybe in the hospital or the laboratories, but not in the daily life, everyday life. You cannot measure your muscle motion or what you are thinking in your brain during sport activities, for example. But if this physical constraint it can be eliminated, then maybe the ultrasound technology has huge potentials. Even more potentials. And the idea towards this goal is to make ultrasound non-contact. This will be enabled by converting the terahertz radiation into the ultrasound. And the idea behind is terahertz waves and ultrasound waves, they are two different physics, but there are some very striking similarity and very striking difference, contrast. So by combining those 2 points, we can efficiently convert the terahertz radiation into the ultrasound. And one demonstration we presented here is underwater communication. This submarine toy, we prepared a water tank of 30 centimeters, and we prepared a submarine toy there inside the water. And we shine the terahertz light to this water tank, and this submarine toy is controlled. So this is a very strange situation. With the previous technology, to enable this kind of situation, we always had to prepare a contact type transducer on the wall of this water tank. But today we do not need any physical contact. So this is non-contact and remote access. And also, in terms of terahertz, this is also a very strange situation because terahertz waves is highly absorbed by water. So terahertz wave doesn't propagate inside the water. But now we can achieve communication because we convert the terahertz waves into the ultrasound at the boundary of those two different media. So this novel approach will enable new possibilities. For example, we regard this situation as a model of our human bodies. So this is a water tank of 30 centimeters, and 30 centimeters is very comparable to our body size, right? So this submarine toy could be a model of the capsule endoscope inside your body, or any other sci-fi micro robots inside your body. Okay, and we also replaced the water tank model with a true human body and demonstrate the proof of concept of ultrasound generation in a non-contact manner within your body. And that was about the inside of our body, but also we can extract information from the outside or the surface of our bodies. And this is done by developing terahertz, what we call terahertz radar. And this radar signal can include some physiological information that can be extracted from your skin. So by combining those two approaches, we can connect the inside and outside of our bodies by using a terahertz radiation. And in the end, I would also like to highlight that terahertz radiation have a potential also for the communication medium. And nowadays, the wireless communication is performed by microwaves or radio waves, but using terahertz waves, due to the higher frequency, we can attain the higher bandwidth. And this higher bandwidth means we have more possibilities to transmit a huge volume data. And speaking of the huge volume data, today, 8K movies or 16K movies, those high-definition movies are always discussed as a representative examples. But we do not think this is the only example. For example, nowadays, FUS, which stands for the functional ultrasound, a novel ultrasound imaging technique, is emerging as a breakthrough in the field of brain science. And there, the functional ultrasound enables to detect or analyze the brain activities by attaching those ultrasound transducers to the skin, head of the brain. Okay, and when speaking of high volume data, the volume data is determined by the product of the spatial amount of the information and the temporal amount of the information. Those two factors determine the amount of information. And as compared to the 8K video or 16K video, this kind of newly emerging technology is still lacking in the spatial amount of the information, but the temporal amount of the information is already surpassing. Therefore, by combining or considering the product or multiplication between those two factors, we see that the amount of the data is already surpassing the conventional examples. So in this way, the human body-related data, or even our neural data, will be a new big data, which can be accommodated probably by the terahertz radiation. So both as a sensing probe and as an information carrier, terahertz waves have a huge potential. So we are working towards that goal. Okay, thank you very much for your attention.
Thank you so much, Dr. Munai, for a very interesting presentation. It's very futuristic, but it's, as I believe, it's our reality, becoming our reality very soon. We now move to Abu Dhabi for our next speaker, who is joining us virtually, Dr. Ernesto Damiani, Director of Khalifa University's Center of Cyber Physical Systems. Dr. Ernesto.
Okay, can you hear me? I don't know if I can share my screen just for showing a couple of slides.
Sure.
Going to present a point of view, which is the point of view of I call the transition of the security and assurance that is happening due to the adoption of artificial intelligence models. So let me see if you can see my screen.
Okay,
I hope that you can see it. Wonderful, you can see it now. And so let me just show you a few slides on this. So basically, the problem is that we live in a world where the most advanced innovation immediately has to deal with the security of the environment where it is applied and the potential threats. So we cannot, we're no longer in an era where technology can be designed and then we can imagine or we can think of how to make it secure and safe for people to use. We needed to do it from the very beginning. So we live in an era where security must be a first-class citizen. And the problem is that machine learning in general, but especially the machine learning that makes decisions about people, about the people, they don't need to be decisions which are individually very important, but they are all decisions that are made every second. The decisions about how to interpret our phonetics of our language in order to translate it into a word, decision on how to interpret the motion in a camera, a motion-enabled camera, how to interpret the motion of an individual in order to provide or to suggest a service. All those are decisions that AI is making, and it is making in the augmented reality, it is making in the metaverse, and it is making also in the physical world. The problem is that these decisions are potentially threatened. So of course, we know that this may happen. We have witnessed the attacks. We can reproduce some of them in the lab. But the problem is that the threat models, meaning a full understanding on the part of the community, the technological community, of the landscape of threats that can affect the adoption of AI for interaction with people is yet to come. So we are at work as a community, and of course the standardization bodies are at work. But this is something that is still in the making. And we have especially potential attacks made by externals, but also attacks made by the user themselves. I mean, if I am using a certain facility, a certain augmented reality environment, I may cheat. And insider cheating is also another big problem in the adoption. So basically, our collective goal must be to strengthen the security and the transparency of the application of AI, especially when making decisions about humans. And I'm not making the example of a decision about, I don't know, giving me a bank loan, which is still a decision about a human. I'm talking of all the small-scale decisions that need to be made by the models about the human behavior, and that are part of the augmented reality scenario and the virtual reality scenario. We need to understand, the models understand what the people are doing and try to react to that understanding. But if there is an attack, if there is a threat, we might end up with consequences that are not the one that we hope. So we need to enable the secure application of ML in the modern systems, especially in the systems for augmented reality and for the metaverse. Also, we need to prevent poisoning at training time of those models. So we all know supply chain attacks. What does it mean? That you buy a subcomponent, and the subcomponent is something that you cannot really entirely test. And so inside that subcomponent, you find out that there has been an adversarial setup of certain inputs, and the component starts behaving as the original manufacturer wanted it to behave, and not as you think it should behave. So it may work very well in ordinary conditions, and then all of a sudden starting doing stuff that you were not expecting, which is particularly a problem when dealing with people, as I said. So we need to be able to verify. Also, and this is all in our world, in the security world, is called more assurance than security. So security is describing the dangers, the threats, and the countermeasures. Assurance is finding a way so we can verify the components, verify the software, verify the devices a priori in order to minimize the likelihood of any threat and vulnerability at runtime when the devices, when the environment are already connected to people. Okay, so you don't have to imagine active attacks on people's safety, although active attacks on people's safety are an important area. But for example, I wanted to check I would like to highlight the notion of the controlling the exfiltration of information. When you are inside an environment, for example, we are working a lot with the Apple device, the Apple new device. You are inside that environment. There is a continuous collection of information about yourself and your movements. This information is confidential, and it must be treated according to the user consent and purpose. So this is not an attack. This is something, though, that is very, very, very important to preserve the user control, or at least the user awareness on how much information about the user micro movements, the user blinking of the eyes, is taken by the device, which of course do it to provide services of augmented reality and of metaverse. But nevertheless, the flow of data is going to be massive, and it's going to contain a lot of information. You may remember that as security people, we used to collect gate signatures, and they are strongly identifying a person. But today, from the micro movements recorded from an immersive system of augmented reality, I can learn a lot about the user. It's not just that I provide the user with a nice augmented reality environment. I am collecting a lot of information that I can use. And this is very important to avoid eavesdropping, to avoid leakages, and to preserve the user control over the amount of information that is revealed, that it is shared with the infrastructure. So here I don't want now to go into the details, but you see an example of all the monitoring data that can be collected during the augmented reality interaction, and how we can use models to evaluate how much information we are providing. No more information than the one that is needed to manage the environment, unless the user authorizes. This is our goal. Reaching that goal is not easy, but definitely when we will live half of our lives in an immersive environment, we are sources of information, continuous monitoring, as much as we are users of the application. So I would like very quickly here to focus on the assurance methodology, which in my opinion is the most important part. Even assuming that the providers of the applications are in good faith, and the service providers in the augmented reality, in the metaverse, will provide the services according to the user SLAs and to the contracts that they will have signed with the users, there is always the potential of supply chain attacks. You don't want an augmented reality environment to become a monitoring for individual people where I will connect information about them. For example, to test for their fitness of work later, or to test, all these things can happen. So we need a methodology for verification, especially to prevent supply chain attacks, where the information leakage is caused by a component that in good faith is added to an environment. So we do both the detection a priori, and here you can see a model in which we basically detect whether the behavior of a model inside a certain device is significantly and statistically significantly different from the behavior of other models, so we can detect what we deviant behavior on the part of specific hardware-software combination. And we can do it also in a peer-to-peer fashion. Sometimes you cannot keep a big brother that is detecting whether certain type of behavior occurs in the field, but you can always have a peer-to-peer checking in which we can verify whether the information that is collected and used by a certain model is consistent with the amount of information that is collected and used by the others in the same situation. So I want to, here we have an example about drones. So I will also finish with, this is a book that we recently published with a number of my students that are now all professors, so I'm very proud of that. And basically there is the wrap-up that I would like to conclude my short intervention with. The first is AI, and when in an augmented reality context, cannot be entirely certified a priori. It needs also a dynamic certification, meaning that you need to be able to check the behavior of the devices and the behavior of the environment at runtime. Of course, you also want to be able to test the visors, you want to be able to test the displays, you want to be able to test the sensors, you want to be able to test the gloves, everything. But on the other hand, you also need to monitor the behavior in the field, because the attack behavior is, especially supply chain attacks, are, let's say, selective in time. They behave normally most of the time. So certification in the lab is not enough. And also, we don't have at the moment yet, although I know of several standard bodies that are working on it, we don't have at the moment yet a clear standardization of how we will verify individually the components, especially the AI models, but not only, the peripherals as well, how we will verify them individually and how we will verify them jointly. Because of course, these are complex pipelines where data is collected and then it is processed by many models. And this is something that we need to be able to standardize when we create an environment for our users. We need to be able to have a verification method for it. And in this book, we tried to make a journey into the evolution of the concept of certification from the certification of the individual device to the certification of intelligent environment, immersive environments powered by AI. I stop here, and I'm happy to continue the discussion.
Thank you so much, Dr. Ernesto, for this amazing presentation and for highlighting the challenges and risks of the use of artificial intelligence, especially that a lot of people nowadays use it in their daily routines and tasks. Our next panelist, whom I'm delighted to introduce, is Professor Abdul Muttalib Al-Sadiq. And he's an adjunct professor of human-computer interaction at the Mohammed bin Zayed University of Artificial Intelligence in Abu Dhabi. Please go ahead.
Ohio. Assalamu alaikum. Good afternoon and bonjour. So that's from me as a human being. And what I am doing, I am trying to go from me to my virtual me to my bionic me. And that's what I call digital twin. And we'll see in the next 5 minutes how I do it. So I am Abdul Muttalib Al-Sadiq, distinguished professor at the University of Ottawa, director of the Multimedia Communication Research Laboratory, and adjunct professor at Mohammed bin Zayed University of Artificial Intelligence. You can follow me on LinkedIn, Instagram, Twitter, wherever you wish to see my digital twin and me in action. So digital twin is not a new concept. It has been here for about 30 years, 3 decades with NASA, and it used to be virtualization of industrial process. And what is better to be a speaker after my colleague Inami and Manai, because they spoke about artificial intelligence, augmented reality, haptics, and so forth. So I decided to change my topic this morning at 7 when I knew that most of you are presenting here. Otherwise, we will be repeating the same stuff about haptics. So digital twin, I redefined it, in fact, in 2017 in an article at IEEE Multimedia magazine to include human being. So for me, a digital twin is a virtual representation of the physical object, system, or process that is continuously updated with real-time data from its real-world counterpart. This digital model allows for simulations, analysis, and monitoring of the physical entity in a virtual environment, enabling improved decision-making, optimization, and predictive maintenance. Digital twins are commonly used in industries such as manufacturing, healthcare, smart cities, and aerospace, where they help to enhance performance, reduce downtime, and foresee potential issues before they occur. Essentially, a digital twin bridges the physical and digital worlds, providing valuable insights for better management and innovation. So technically, this video took me literally 1.5 minutes to create. So it's not me who was speaking, it's my voice. And it is my image and deepfake. Basically, I have the whole pipeline. So that's where I consider the first step toward integrating AR, VR into AI, and then making use of something we consider always bad, deepfake, into something good to help me in teaching. Because today I am here and was teaching overnight in Ottawa in my own metaverse. It's called zapaura.com. So I teach in Zapaura. My digital twin helped me in teaching, and sometimes it helped me explaining some topics. So I brought this digital twin to the human being, and the reason why I was asked a couple of times, why I talk about digital twin. I am a multimedia guy, and multimedia, as you know, talks about multiple media from text, audio, video, augmented reality, virtual reality, haptic, and so forth. But multimedia alone without communication doesn't make sense, so we need to understand communication networks and communication protocol. And we need to do it very fast. When we interact with this environment, we create data, and we want to make sense of the data. Here where AI comes into question. Now, when we make sense of the data, we need to transmit the data to continue interacting with it, and here where human-computer interaction comes in terms of a humanoid robot, as my colleague here presented this morning, haptics, AR, VR, and everything needs to be done in a private and secure way. So what makes the digital twin unique? It makes it that really now we can look at it not only from a cyber physical world, but cyber physical AI security, augmented reality, mixed reality world, putting it so together that we can really now think about any interactions that we perform in this real world to be transmitted to the virtual world, and vice versa, as I will be showing you later on to application domain. Why it is important, how I convince, I mean, I don't need to convince my student to work on digital twins, they are convinced already. However, every year I bring the new Gartner radar, and every year I see the digital twin bold blue, that means very high importance, and it's going from dark gray into light gray, which means it's coming to the practical environment, which means graduate students have a better chance to find a job if they work and understand digital twin with its surroundings, spatial computing, AI, and metaverse. The digital twin can enhance the quality of life, and particularly when we talk about aging society, but also non-aging society, single people living in the north in Canada or living somewhere in villages. So in the healthcare, a stroke could be predicted way in advance if we are collecting a lot of information, and we are very, very basically unaware on how much information can we collect just by having a smartwatch around our wrist, and how much we can basically know about ourselves and predict the next, basically not only emotional state but also potential health risk. I'm not going to talk about other social aspects of digital twin, but one of them is probably dating. Now, the question is that always people ask me too, and last week I was in GAIN Summit in Riyadh, and people ask me, will AI augmentation empower human or enslave them? So before I answer this question, I asked my digital twin who went to GPT, and he came. AI augmentation has the potential to empower humans by enhancing our abilities, improving efficiency, and solving complex problems. However, without responsible development and regulation, it could also lead to negative consequences, such as loss of autonomy or increased inequality. Ultimately, whether AI augmentation empowers or enslaves us depends on how we choose to integrate and govern these technologies in society. So the second question, what will be? Can we afford it? And if we afford it, do we have a divide in our society? And automatically will come to say yes. However, my digital twin, when he went and he checked between Gemini, ChatGPT, JAIS, and Falcon, he decided to come with the following. AI augmentation can create a divide between those who can afford it and those who cannot. As advanced AI technologies become integral to enhancing human capabilities in areas like education, healthcare, and employment, individuals and organizations with the resources to access these technologies may gain significant advantages. This could lead to increased socioeconomic disparities, as those without access may be left behind in terms of opportunities and competitiveness. To address this potential divide, it is important for policymakers, businesses, and communities to work together to make AI augmentation more accessible and affordable for a wider population. So you see, I don't need to talk in any presentation anymore. I prepare my digital twin 1 hour before, and literally I prepared the presentation from 7:30 to 8 a.m. So within half an hour, the whole pipeline. Now, digital twin with the enhanced haptic, robotic, AI is here to serve humanity. I'm just giving you here 2 examples on where ALS patient unable to do anything but moving their eye to interact with their eye, they can drive a robot enhanced with different type of sensors, actuator into their home, and therefore the digital twin in this case is not a real digital twin, is a bionic twin, it's a wheelchair. The other example there is during COVID, where we decided to 3D print a robotic arm to feel the handshake for people at a distance, as a matter for elderly people to feel the handshake of their parent. A robot arm exactly the size of any one of us can be 3D printed, sensors actuator can be added, and then the handshake will be measured and transmitted to the counterpart in real time to feel the handshake on the other part of the world. Sumit, I believe I have a couple of questions for you, and you have a couple of questions for me at the end. I thank you for giving me the opportunity to be here for 10 minutes, and we'll be happy to answer questions later on.
Thank you so much, Professor. I believe everyone agrees with me that's a very interesting presentation, especially that you made it in just half an hour. Maybe we could sit together and you teach me after that. Our next and final panelist is Ms. Amina Al-Marri. She's a researcher at the Autonomous Robotics Research Center at TII from Abu Dhabi, UAE. You have the floor.
Good afternoon, everyone. My name is Amina Al-Marri, and I am a master graduate from Spain in intelligent robotic systems. And as Sumaya said, I'm a researcher at ARRC in TII. I'm glad here to be today to present to you how my vision about AI system integrated with the robotics in terms of healthcare, especially making sure that it is serving the elderly. So in 2020, the United Nations released a report in regards of the population of elderly people, which means 65 years and above, and it was calculated to be 727 million person or people, and it is suggested that it will be an increase up till 1.5 billion by the year of 2050. As we are aware, older adults require more attention and they need help and continuous monitoring. This is a critical point for those who are living alone or lost their families, especially the ones who cannot afford the healthcare workers to be with them. We are in the technology era where we have developed many solutions for this problem, and I would like to categorize it to two different types. One is the sensor system, and the other is computer vision systems. Let me elaborate more in terms of fall detection for elderlies and how it can work. So sensor-based monitoring systems, they are devices that are attached to human body. For example, the smartwatch that we have is a monitoring system that continuously takes the data of our heart rate or our oxygen level in the blood. These devices are critical in terms of measurement. However, if we want to detect fall detection, it is necessary to have it as a vision, but the researchers found a way to build a device for fall detection for elderlies. This system is affordable and easy to develop. However, having it to be attached to elderly's bodies is critical, as it needs to be continuously on the body, and this might create irritating for people. So how we can eliminate the attachment issue? So using computer vision algorithms, we are able to define and detect humans in the videos or images. As you can see over here, we have an example of a person running on the stairs, and then running this video into an algorithm, we were able to detect the person running with some joints indicating the person. This is still detection and not predicting what this person is doing. And here we need AI, where it is a deep learning network that understand and formulate the equation to solve to understand what we are doing in the images. So based on the research, comparing the sensor systems and vision monitoring system, the result was to have better or higher accuracy using the vision rather than sensors. And another paper concluded that using deep learning models can achieve better results. As we can see over here, one of the published vision language models called VFED. This model is created to detect fall detection, and after testing it, it has an accuracy of 99% of accuracy. Let me explain to you how the training model works. So first of all, we need a training data. This data is essential, and we have to choose it wisely because it can determine how we train and build the brain for the machine. In this paper, they used some camera feeds from different angles of people falling incidents. Later, the next phase is to pre-process the data. We have a data of images or set of images acting as a video, And then to let the machine understand what we are feeding it, we need to resize the data. We need to reorient it to make the machine able to understand it. The next phase is feature extraction, and here where we train the model, we teach it to learn what are the critical or essential part of the video that is fed to it. Later, we can fine-tune it to be more specific in terms of the parameters that we want it to see, or focus on specific results. After that, we have the output generation, and this could be an image, a bounding box on an image, or a caption for the image itself. This is what we are working on to make the last step is to have a command to connect to robot where it can build or do the work for us based on the output of the VLM. Another paper showed us the ability of understanding the hand gestures to send messages to the authorized person in the system to understand what is the elderly is asking for. So for example here, having the gesture of one send a message saying that this person needs water. The limitation of this system is that the person must be viewed in the vision for the sensor. This raises for us the ethical consideration, which is the privacy of this person. And we found a solution for that by changing the person in the data transmitted all around to be as an avatar of 2D person. Finally, in conclusion, as AI continue to evolve, we stand at the threshold of a new era in advanced healthcare, where machines may not only detect and monitor healthcare issues, but it can also predict and recognize them early. Thank you for listening. I would like to answer some questions.
Thank you so much, Amina. And I would like to ask you a question. Since you work at the ARRC, how do you think a collaboration between and among researchers advance the field of body augmentation engineering?
It is actually essential. From my research work, I think it is important to have different fields to be connected together, as we are dealing with the integration of machines with humans. It is critical when it comes to parts where we need to enhance it or to adapt it to human body. So we need, for example, a neuroscientist to validate or authorize us to do such thing.
Thank you so much. And I will now open the floor. I think we have about 5 to 7 minutes left in our panel. In general, and as in other areas of AI development, what steps can be taken to ensure that technological development proceeds in tandem with societal, regulatory, and ethical considerations? I will just open the floor to anyone who would like to answer this question.
We can go whoever you want. Okay, so I believe that's one of the most heated discussion at the moment. How do we balance between technological advancement and ethical societal expectation? We need first to understand that AI by itself is just a tool. And how we use it, it's up to us. We can use it for good or we can use it for bad. However, those ethical aspects are not universal, because ethics usually is what we call it's cultural related aspect. There are ground truths for everything, but there are different direction on what's ethical or what level of ethics it is applied in what society and the other. So technically we need to, we cannot have one solution fit all. It is really adaptive, and we need to be agile as we are developing technology, to be agile and to do a design, basically to do AI ethics by design, is not by later on, really from the ground up.
So may I add?
Yeah,
So
please
one
go
thing
ahead.
that relates to, I totally agree with, so scale issue is so not global issue. So so we need to localize, and so we also carefully connect so individual societies. And also, I also feel, and this is somehow related to question to Dr. Damiani. So you mentioned that's a security issue for AI. But I also think, so based on human AI interaction and integration, we also care of somehow security for our mind or cognitive system. Because so recently, so one researcher published quite a unique paper that is so we can be hacked by so AI, easy to be hacked. So based on communication or conversation with AI can easy to so make a sort of fake memory to a user. That's why so AI is not only so technical issue, but also we need to some physiological system or neuroscience or various system. So that's why. So my answer or my point is okay. So local society issue is important. Also physiological, or we also need to understand our human being.
Thank you very much. So I have
If
the next.
you may add one line, just because I've
Yes, of
been
course.
mentioned. So it's really, I want to be very concrete on this, because I think this is a general debate, and what my colleagues have mentioned are all very important principles. But then there is the concrete code of conduct in the industry that we need to be aware of. For example, I would want to quickly discuss the competing approaches to immersive augmented reality and metaverse. I mean, the devices of Meta, the devices of Apple. In all cases, there is a model of privacy that the recorded micro information on the user behavior that is important to have the impressive results, for example, on the digital twins that I saw before. This is very important, but on the other hand, it is under the control of who? The device manufacturer, the service provider, the application developer. For the moment, we are seeing models in which the privacy and the security of the data flow that is about the micro behavior of the users is under the control of different actors. And it depends a lot also on business strategy of the different actors involved. I think that we need a community level reflection on this, because this is very important. It's going to be the next stage in which, instead of being monitored every 3 seconds, you are monitored every millisecond, because of course, in order to provide synchronization, you need to do that. But where goes that flow of information in addition to going to the environment or the immersive environment where you are working? Who is reading that sequence of events? So this is, in my opinion, a crucial point for the security and privacy of immersive augmented reality architectures. So stop here.
Thank you so much, Doctor. I actually had a question. If you can let us know what strategies can you recommend to both individuals and governments to limit the risks of oversharing information?
Well, I can only recommend to governments, of course, to keep an eye on the providers. And of course, we have two very different philosophies between Apple and Meta. So at the moment, I think that the first thing that the governments and the community needs to do is to be informed. So know and interact. And then once you enable and license, for example, in education, I'm just dropping one here. For example, in education, when you develop and license integrated systems that will not be longer used by pioneers only, like the ones we saw today, but will be massively introduced into the educational system, for example, When you do that, you need to make sure that you have the regulatory framework in place. And in the UAE, I know that the government is very aware of this, and they want to keep an eye. But this should be worldwide. We shouldn't leave it to the industry. Sorry, I love the industry, but of course, the industry is strongly motivated by the business principles, by the business, by the profit. We need also to have this type of governmental control over this amount of information. So first of all, we need the governments to know, to be prepared to write the principles. And then, of course, regulatory framework will follow.
Thank you so much, Doctor. And I would like to conclude with a question to Professor Monai. So I just wanted to know, what is specifically is about AI that has enabled taking body augmentation to the next technological level?
Okay, to the next technological level, or the impact on the society, which will be...
Yes, the impact on society.
Okay. Maybe the important thing nowadays, especially in Japan, is to maintain not only the long life, but also the healthy life. And this health not only means the physical health, but mental health, of course. And we think we are working on the augmentation, and augmentation, to implement human body augmentation, we of course need a lot of AI-based, AI-driven technology. And AI we use for body augmentation. And the reason why we are focusing on body augmentation is that we think body is the interface to access the inside of ourselves. I mean, inside means our mental thing, mind, and also emotions. Those things can be accessed through the body. So, for example, speaking of the aging society, the important thing is, of course, to maintain the health, and to do that, to some extent, we need some physical barrier or physical bars. I mean, if everything is automated, we do not have to use body anymore, and that probably spoils ourselves. So we need some physical bars and physical challenges, but we do not need mental stress to challenge those physical bars. So AI-driven human body augmentation technology can slightly help us in a physical sense, but this slight help in the physical sense leads to the very great health of our mental health, and makes us feel happy and getting more self-esteem. Those will lead to a brighter society. That's what we think.
Thank you so much, Professor. So as we come to the end of our panel, distinguished guests and participants, we have now completed the panel on AI and the reorganization of the body-machine society relationship. Panelists covered much ground explaining technology and science, social challenges, and the ethical and governance approaches, for which I extend my utmost thanks and appreciation. I would also like to thank the audience for their attention and interest, both at these wonderful premises here in Japan, as well as those following us from the UAE. Our session is now complete, and I wish you an enjoyable concluding session which delves into the critical topic of AI development and political governance. Thank you so much.